students, in this part we will study about the other terms related to electrolysis. We have studied about the electrodes, the types of cells and other parts. Now we have to study about the electrolytes and its types. Electrolytes. Now, as we know, as we have studied, that an electrolyte is a chemical compound, generally ionic compound, which allows electric current to pass through it in molten or aqueous solutions. That is, the chemical compounds which allow electric current to pass through it in molten or aqueous solution state are called electrolytes. Now we study here, students, the electrolytes, that is the chemical compounds, are of three types: a strong electrolyte, weak electrolyte and non-electrolyte. Now actually the electrolytes are differentiated as a strong or weak on the basis of degree of dissociation or ionization. The degree of dissociation or ionization is the extent up to which a substance changes into ions, ionize or dissociate into ions in molten state or aqueous solution state. It is denoted by alpha and expressed in percentage. This topic has been already studied by us in acid base chapter. Now here we will directly use this information, that is, up to what extent it is changed into ions. So now we see that first of all there is a strong electrolyte. A strong electrolyte. Now just you see, a strength is determined by alpha, that is degree of ionization or dissociation. Dissociation for ionic compound and ionization is used for polar covalent compounds in aqueous solution. So alpha greater than 30%, that is degree of ionization or dissociation is more than 30%. Now since there is a higher degree of ionization or dissociation, so there will be higher concentration of ions. So we write here they mainly consist of ions. Mainly consist of ions. Now you see, a student, we have used the term mainly, that is almost, means there will be very little molecule, but we will not write only, because no substance will ionize or dissociate 100% in aqueous solution or in molten state, because ions recombine to change into molecules. So it consists mainly of ions. Now they allow large amount of electric current to pass through them, and one more point, like in the previous example we had connected a bulb in the circuit. So if we use a strong electrolyte in the vessel, the bulb will glow brightly. So we also write here the bulb connected glows brightly. So these are the 4 points explaining the strong electrolyte. Now example, in the strong electrolyte These are strong acids like dilute HCl, dilute H2SO4, dilute HNO3. These are the strong acids, hence they are the strong electrolytes. Similarly, strong alkalis like NaOH, KOH, KOH, and barium hydroxide, although it is not given in the our part of syllabus, but barium hydroxide is also a strong electrolyte, as well as all alkalis will be a strong electrolyte. Alkalis means that is that of alkali metals. And now the salts. Salts here we write that is molten or aqueous NaCl, KCl. Similarly, molten PbBr2, lead bromide, aqueous cupric chloride, aqueous copper sulfate, aqueous silver nitrate, etc. So these are the strong electrolytes. Now, generally ionic compounds are strong electrolytes. They conduct electricity in molten or aqueous solution state. Now there is a weak electrolyte. Weak electrolyte. We explain it again on the similar points, basis of points. Alpha less than 30%. Now, since there is partial ionization or dissociation, so in the solution there will be also the presence of molecules. So we write here they consist of ions as well as molecules. Ions as well as molecules. So we remember here, it will not be just these type of points have been already clarified in acid chapter where we have discussed in detail. Now they allow a small amount of current to pass through them, and finally we can write that is the bulb connected glows dim. Since little of current passes through it, flows through it, so the bulb, if connected, will glow dim. Now then, example, this time we will take weak acid like carbonic acid, sulfurous acid, phosphorus acid, acetic acid, that is all organic acids, etc. Now weak alkali. Now here there will be CaOH whole twice aqueous, NH4OH. These are weak alkalis. And some salts like you see, suppose there is lead acetate solution, etc. So these are weak electrolytes. Actually, the strength, strong or weak, is similarly explained in case of that is similar to that of the acids, weak and strong acids, weak and strong alkali, and so on. Now, third one, that is non-electrolytes. As the name suggests, they will not allow electric current to pass through it. Means they will not ionize or dissociate into ions. So that will be non-polar covalent compounds. Now that is, they consist of only molecule. They consist of only molecules. Only molecules. So they do not allow current. They do not conduct electricity. They do not allow electric current to pass through it, and hence bulb does not glow. Bulb does not glow. Example: distilled water. Most important, actually we have taken that water is a polar covalent compound, but if it is pure water, it will not conduct electricity, it will not ionize. Similarly, now we write here carbon tetrachloride, which is an organic solvent, chloroform, alcohol, benzene, acetone, petrol, etc. So these were the different types of electrolytes. We have described the types of electrolytes used in the process of electrolysis. Now, students, we have to further study. That is, we know that ionic compounds are used as electrolyte. They have ions, they conduct electricity. But here you have to remember that in which condition they will be able to conduct electricity. So we take the heading conduction of current by chemical compounds. Chemical compounds, or generally which are actually ionic compounds. We study here that ionic compounds do not conduct electricity in solid state, but they conduct electricity in molten or aqueous solution state. Now we have to study here the reason for this point. Why do the compounds perform these properties or show these properties? First, in solid state. In solid state, the oppositely charged ions are strongly held by electrostatic force of attraction. So the ions are not freely mobile. That is, ions are not freely mobile. As a result, we see that they will not be able to conduct electricity in solid state. Now, then molten state. As we know that ionic compounds have high melting point. So the large amount of heat required breaks the force of attraction, that is increase the kinetic energy of the particles, and they break the force of attraction between the ions. As a result, when they melt, ion become freely mobile. So we write here the large amount of heat required to melt the compound, break the force of attraction, breaks the force of attraction between oppositely charged ions, and they become freely mobile. So they conduct electricity in molten state. Now, what happens in the aqueous state? Now, as we know that water is a polar covalent compound. So when an ionic compound is dissolved in water, then the partly ionized or partly charged oxide ion, that is oxygen atom, attracts positively charged ions towards itself, and the partly ionized H plus having a delta plus charge will attract the negative ion. Hence, the force of attraction is broken. One more term which we use here, which we'll study in higher class actually in detail, that is water is a polar covalent compound and has high dielectric constant. This term, students, actually you will study it in higher class in detail. Dielectric, di means two, electric means charge, polar covalent compound. So now you see here, that is the oxygen atom, that is oxygen atom from water having delta plus charge attracts negatively charged ion, negative ion from the compound, from the ionic compound, and hydrogen atom having delta plus charge, oxygen atom from water having delta minus charge attracts positive ion from the ionic compound, and H atom having delta plus charge attracts negative ion towards them. Hence the force of attraction between oppositely charged ions is weakened and they become free and they become freely mobile. So just a student, we see that ionic compounds conduct electricity in molten state or aqueous solution state. So we have studied about conduction. Now a student, one more thing which we have to study, actually we say the principle of electrolysis or Arrhenius theory of electrolysis. Generally question is not asked from here. And what happens in this part? Actually the different points of electrolysis which we have studied will be taken together. In principle of electrolysis or Arrhenius theory of electrolysis, the simply terms are taken together. Like according to Arrhenius theory, first point, it says that the ionic compounds form ion, produce ion when dissolved in water. But according to modern theory, it says that ionic compounds already consist of ions. They only dissociate into ions when dissolved in water. So this is the first point, that is ionic compound dissociate into ions in aqueous solution. Second, the freely mobile ions are responsible for conduction of electricity. Second point. Now we see the third thing. Cations migrate towards cathode, anions migrate towards anode, and they are discharged there. Fourth point. In electrolyte, there is an equilibrium between unionized molecules and the ions. The reaction is reversible. That is, when the ionic compound dissociate into ions, then in the solution ions again come closer, oppositely charged ions come closer to form the molecules. So there is an equilibrium between them. So these are some of the points which is discussed in principle of electrolysis or Arrhenius theory of electrolysis. Now clear, student? So we will go through the topics now. Next topic which we have to study here, that is called electrochemical series. Electrochemical series. Now what is electrochemical series? Actually the electrochemical series is the series of ions which is made by arranging the ions in sequence, that which ion will be discharged more preferentially. That is, when ions are arranged in increasing order of the ease means how much easily, of the ease with which they are discharged at electrodes. When ions are arranged in increasing order of the ease with which they are discharged at electrodes, then the series so formed is called electrochemical series. Electrochemical series means we see here, that is, in this series the ion which will come later, which will come down, will be discharged more preferentially on the electrodes. Now we see that electrochemical series will be for the cations and anions, that is for both the types of ions. Now, so first of all, write the series for the cation. Actually, this series is taken similar to that of the metal activity series. but there is one difference, that calcium ion comes before sodium ion. So this series is K plus Ca2 plus Na plus. Now then here we see Mg2 plus Al3 plus Zn2 plus, and here iron 2 plus. Now in metal activity series, after iron we will take lead generally, but here we will have two more ions taken which are used in electrolysis, so we prefer to take these ions also. Now Pb2 plus, H plus, Cu2 plus, Hg2 plus, Ag plus, Au3 plus, and platinum 4 plus. So actually this is the ease of reduction. Ease of reduction means that is more easily, as we come down, the ion will be discharged at the electrodes more easily. The reason is that the metals above are more reactive, more electropositive in nature, so their ion will not receive electron easily. But those which are less reactive metals, their ions can more easily gain electron in comparison with the upper metallic ions. Now, similarly, we take another part, that is the anion. Anion. Here we take sulfate ion, nitrate ion, now then chloride ion, bromide ion, iodide ion. Then actually in the book after that hydroxide ion is given, but we will introduce one more ion here, that is this one, and then OH minus ion. So this is for the anion, and it is for ease of oxidation. Since the anions will migrate to anode and they will lose electron to become neutral, hence there is the oxidation. So just we see here, that is in this series the ions which are placed lower will be more easily discharged at the electrodes. Clear, students? So this is about the different terms, factors, different terms studied in electrolysis. In next part we will study about the preferential discharging of ions. That is, if there are more ions, more than one cation or anion in the series, in the solution, then which will be discharged preferentially. Clear, students? Thank you.